Yeah, so my name is Casper. I'm currently a PhD candidate here at the University of Amsterdam, and meanwhile, well, also started doing some activities to connect my research on, well, essentially dynamical modeling applications for society and mental health, to connect it to the real world, so to speak. And of course, these problems of causality then become even more important when you want to actually affect a change in the world. So my affiliations in that sense reflect, wait, I don't know if you see this box, reflect that intention. And what I want to go through is essentially review different parts of the kinds of models that I use and we use in this network. The Nested Minds network is an international network of researchers that are affiliated with various universities and essentially interfacing with the corporate world while keeping the central research products open access. So we're kind of experimenting with ways in which we can allow society to benefit from academic work without having it locked up behind patents and all those kinds of things. So part of that, so director of modeling, that's like my recent, something more recent is where we're working on a spatial web of components of society. Can be companies, can be hospitals, can be also within, let's say, within people's own social network. We basically apply this web network modeling to help people make their lives better, help companies make their companies more, their organization more efficient or more suitable for mental health. And that's one of the important focuses of my research. But just to get a little bit around all the, let's say, thorny philosophical issues, I usually start with this point made long ago by a very intelligent man who just said all models are wrong, but some are useful. So this follows very closely with the approaches outlined by some of the previous speakers, where essentially looking at viewing as causal relations as hypotheses to be tested and being usually only approximations of what's happening. But essentially, I'm just going to run you through the way we're doing that modeling. And well, the first step is to ask this question of what are the states, the hidden states of the world, here denoted with S, that generate the observables. So essentially viewing the observables as some outcomes that are generated by the processes occurring in the world, and the hidden states reflecting the current status of those processes. So we're essentially, this is a model that, well, a conceptual way to think about perception in general, but in this case, applying it to me as a researcher, trying to perceive the world. So that also aligns quite closely with the first speaker's point that actually we as researchers ourselves are only part of that story, and not some kind of entirely external observers. Essentially, what we want to do, we don't only want to perceive, we want to understand, we want to know how past hidden states influence the future. And again, this is very much in line with what, for example, Laurens was talking about. So now we start, instead of just perceiving the world, we want to know how those hidden states of the world evolve over time. We go one step further. In the interest of time, I should watch it. So once we've once we have that kind of understanding of how the world tends to evolve, we can start thinking about action. So how do we influence the future towards desired outcomes? Here the actions are denoted with U, but essentially modulating the relationship between the past and the present and the future. And then the question is, how do we obtain, well, desired outcomes? And of course, that requires you to specify what desirable outcomes are. And once you're doing that, and that's again a point already made by Lawrence in the end, is the question of how well are we doing in affecting these desired outcomes. So in this case, it's indicated with a precision that essentially sets our confidence in our action model, in how well we're able to do that, to affect the desired outcomes in the world. So this moves to some extent after, let's say, you've got some causal grip on the world based on your interventions, then the question becomes how reliable is that particular grip? How much do you have to update your action model? How much do you adjust interventions? And just as a worked example that I've been recently working on a lot, is this example of a hidden state, set of hidden states, a dynamic causal model that aims to capture the daily rhythms of participants in a very simplistic way, essentially. Starting out like this, you can make it more complex as you go. Essentially, viewing it as a system that's being driven by light as a fundamental kind of driver of our daily biorhythms, but also by our daily schedules. So I will run you through it a little bit. Essentially, you can see here you have some kind of activity cycle that runs through sleeping, waking, working and leisure activities, and back to winding down before going to sleep. Essentially, these activities are all related to typical arousal levels. But conversely, like current arousal levels will drive the way in which you can transition from activity to activity. So if I'm in a very low arousal state, it's hard to transition from waking to working, so to speak. And the other way around, if I'm very highly aroused, it's hard to transition from winding down in the evening to actually getting to sleep. Essentially, this is an example. I also have some data set to share on this, but I think I don't have time to go into that. But the basic idea is that the things we have access to, here we have self-reports, daily self-reports in this case, but we have objective measures where we use like wearable sensing devices, so we can get measures directly from people's bodies, and then see how these hidden states of the world how well they can do in explaining the observations, and then recursively, so this is my last slide, recursively fitting to each individual participant. So the very important part here is it's idiographic data. We have a generic structure of the model, but we apply this for individuals. So we get an individualized, just again, like what Lars was talking about, an individualized network architecture. The parameters of that specify the relations could be different for, let's say, individuals with hypersomnia or insomnia or different kinds of problems or lifestyles. But essentially, just to summarize, this example was meant to illustrate the way in which these 4 steps come back in my research. So the step of inferring hidden states that generate available data, and that would be the perception part, and then testing hypotheses on their causal relations within individuals. And we can be actually pretty agnostic about what is truly causal here. It's just that the assumption is that the best model that's possible would be the most accurate reflection of the causal structure. And we never know what is the truly best model. Fortunately, we can test them, and one of the most important ways you can test them, once you have these real-time data, you can design personalized interventions based on somebody's personal network model, and then monitor and adjust these interventions in real time. So essentially, that comes actually back quite nicely to the point in the last presentation before me, because once you start doing manipulations to the system, you can actually start to test, or more directly start to test those causal relationships. And of course, that's very relevant for therapeutic work, because lots of the current methods are based on group level data, clinical data, where like insurances only pay for things that are validated on the group level. Well, actually, we know that we actually need methodologies that dive into the individual level idiosyncratic nature of these different processes. So thank you for listening, and yeah, you can always email me if you have further questions after the discussion.
Okay, thank you so much, Casper. That was also very interesting and allowing us to delve into yet another case.